In this question, it is given that let S be the set of all alpha beta where alpha and beta lie between pi and 2 pi, for which the complex number this is purely imaginary and the complex number this is purely real. Let us define z alpha beta as equal to sine 2 alpha plus I cos 2 beta, where alpha and beta belong to the set S as defined above. You have to find the sum of I z alpha beta plus 1 upon I z bar alpha beta, where alpha and beta both belong to the set S. Note that here you have to take all possible values of alpha and beta and use them here and finally add those values. First of all, let us find the value of alpha and beta. To find the value of alpha, I'll find the real part of it and put it equal to 0 because it is given that this is purely imaginary. To simplify this, I proceed as 1 minus I sin alpha upon 1 plus 2 I sin alpha. To simplify it, I multiply divide by conjugate 1 minus 2i sin alpha upon 1 minus 2i sin alpha. This is equal to 1 minus 2 sin square alpha plus I get now as minus 3 sin alpha upon 1 plus 4 sin square alpha. And now I put the real part of it equal to 0. I get 1 minus 2 sin square alpha upon 1 plus 4 equal to 0. I get cos 2 alpha equal to 0 because 1 minus 2 sin square alpha is cos 2 alpha. And 2 alpha is equal to 2n plus 1 pi by 2. That is alpha is 2n plus 1 into pi by 4. And where n is any integer, but only that value of n will be taken for which the value of alpha lies in the interval pi to 2 pi. Clearly, for n equal to 2 and 3, the value of alpha will lie in the interval pi to pi by 4. For n equal to, I get the answer 5 pi by 4. For n equal to 3, I get the answer 7 pi by 4. Hence, the possible values of alpha are these two. And next step is to find the imaginary part of it. And for finding the imaginary part of it, it's not required to simplify this again as I had simplified this here. Actually, in examination, every second is very important. It is very clear from these two that the difference between these two is wherever there is I, here it is minus I, and wherever it is sin alpha, here it is cos beta. And it clearly means if I had simplified this and got it, after simplifying this, here I will be getting 3 cos beta. Agreed? You can solve it, but because every second is very important, therefore imaginary part is going to be 3 cos beta and I will put it equal to 0, and putting cos beta equal to 0, I get beta equal to 2m plus 1 into pi by 2, where m is any integer, but I will be taking only that value of m, so that the value of this lies in the interval pi to 2 pi. Clearly, for m equal to 1, I will get the value of beta as 3 pi over 2, and it lies in the interval pi to 2 pi. Hence, all possible values of alpha are 5 pi by 4 and 7 pi by 4, and all possible values of beta are 3 pi by 2. And because S is a set of all the ordered pairs alpha beta, hence S will become 5 pi by 4, comma 3 pi by 2 and 7 pi by 4, comma 3 pi by 2, because first place is to be filled by all possible values of alpha, second place is to be filled by all possible values of beta. Had beta got two values, then there will be 4 ordered pairs. Hence, using this, all possible values of z alpha beta will become sine 5 pi by 2 plus I cos 3 pi, and second possible value of z alpha beta will be sine 7 pi by 2 plus I cos 3 pi, and this is equal to 1 minus I, and this is minus 1 minus I. Hence, becomes equal to I into 1 minus I plus minus 1 minus I plus 1 upon I into 1 plus I plus 1 upon I into 1 upon minus 1 plus I. That is I into minus 2I plus minus I into 1 upon 1 plus I plus 1 upon this is equal to 2 plus minus I into minus 1 plus I plus upon minus 1 minus 1. That is 2 minus I into 2I upon minus 2. That is 2 minus 1 equal to 1.